Welcome to Man Does Tech, where I solve the problems you didn't even know you had.
You start by verifying the function's domain and whether you're on a closed interval. This matters because absolute extrema require checking endpoints. Once done, take the derivative f, x, immediately and solve f, x equals 0, also mark where f is undefined. Make sure to write down the exact x values for endpoints and all critical points. This gets you the finite set of candidate points to test. Don't delay. Gathering candidates first prevents missing a crucial location later. You now compute f, x, carefully and solve for zeros using algebraic techniques. Factor, use the quadratic formula, or substitution as needed. Once you have roots, examine any points where f does not exist and include them as candidates. Make sure to consider multiplicities because a repeated root can alter whether the point is a max, min, or neither. If helpful, sketch a quick sign chart. This shows how f increases or decreases around each candidate and why. You finish by plugging every candidate x into f, x, and listing the resulting values in one column so you can compare them directly. Once done, identify the largest value as the absolute maximum and the smallest as the absolute minimum on your interval. Make sure to state the point and value pair for each extremum. If results look off, recheck algebra for roots, confirm you included endpoints, and ensure the interval was correct. That single check often resolves discrepancies.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.